Okay, so we have discussed the RDT 2.0, and now RDT 2.0, it has a flaw. And what is the flaw? Let's explain it. Because we have computed the checksum for data, and we are sending acknowledgement and negative acknowledgement for data, not for acknowledgement. And what happens if the acknowledgement or negative acknowledgement becomes corrupted? Because the sender doesn't know that what happened at receiver. Okay, so what does it mean? It means that suppose here this data is sent and the data is received without error, and the sender sends the acknowledgement, but this acknowledgement, it becomes negative acknowledgement. When the sender receives negative acknowledgement, what it will do? It will resend the packet. So it means that packet is arrived twice. Okay, it is redundant. When the packet is arrived twice and that packet will be delivered again, the retransmitted packet is received without error, so it will be given to the application. So the application receives the same data twice. So if the acknowledgement is sent and that acknowledgement becomes negative acknowledgement, because the bit error can happen in the acknowledgement as well, and the negative acknowledgement as well. So if the receiver sends the acknowledgement and the way it becomes negative acknowledgement, so what will happen? The sender will retransmit the same packet and it is received again correctly without error, so it is delivered to the application twice. So this is called duplicate. And now again, if the sender sends the acknowledgement, suppose this happens, that the sender sends the packet and the packet is received with error, corrupt. So what will happen? The receiver discard the packet. What does it mean? The receiver doesn't give this packet to the application layer, and the receiver sends acknowledgement, but on the way the acknowledgement becomes negative acknowledgement. The receiver sends negative acknowledgement, and on the way the negative acknowledgement, due to bit error, it becomes acknowledgement. When it becomes acknowledgement, so what will the receiver do? Receiver will discard this sent packet and it will wait for the next packet. It will send the next packet. So it means that this packet is not delivered to the application. So this packet is lost. Okay. So this means that if acknowledgement and negative acknowledgement, it can also get corrupt. So should we again do the checksum for the acknowledgement and negative acknowledgement, and when the acknowledgement is received at the sender, so the sender should again send acknowledgement for this acknowledgement. What should we do? Okay. So this has a flaw, that the acknowledgement and negative acknowledgement, it can corrupt it. It can have bit error. So if it can have bit error, that means acknowledgement can become negative acknowledgement and negative acknowledgement can become acknowledgement. So what should we do? Should we have the feedback for acknowledgement and negative acknowledgement? Okay. So this is impossible. What we do? First of all, there are two things. Number one, the chances of errors in acknowledgement and negative acknowledgement is very, very, very low. it is negligible. Why? Because acknowledgement or negative acknowledgement is just one bit message. It is just one bit message. And the data is more than one, it is a large number of bits. So the error chances in a large number of bits is more as compared to the error chances in one bit. So it is, first of all, it is the chances of error in negative acknowledgement and acknowledgement is less. So therefore we don't use the feedback mechanism for acknowledgement and negative acknowledgement. However, we use the checksum mechanism for acknowledgement and negative acknowledgement. Okay. So, but still, if we don't use the acknowledgement and the feedback mechanism for the acknowledgement and negative acknowledgement, then still there can be duplicate packet. Okay, so as we know that we use the checksum mechanism for acknowledgement and negative acknowledgement. Okay, so if sender retransmit current packet if acknowledgement or negative acknowledgement is corrupted through the checksum mechanism, the sender can note it, the acknowledgement or negative acknowledgement is corrupted or not. If it is corrupted, then it retransmit the packet. Okay, but this can lead to duplicate packets. That can lead to duplicate packets. So how should we detect the duplicate packet? So we can detect duplicate packet through sequence number. That's why we attach the sequence number to each packet. Why? In order to detect the duplicate packet. So the flaw is, what is the flaw? The flaw in the 2.0 is that the negative acknowledgement and acknowledgement, it can corrupt it. So it can corrupt, so we don't use the feedback mechanism. For acknowledgement and negative acknowledgement. So it means, why? Because the chances of the error in the acknowledgement and negative acknowledgement is very, very low. But still it can happen. So if it can happen, then what we do, we already explained that there are two chances. Either the packet can be duplicate or packet can be lost. So for this purpose we use the sequence number. Okay, so we are using the stop and wait protocol. Stop and wait means that one packet is transmitted at a time, and until and unless the first packet is not received, the second packet will not be retransmitted. Again, I can explain it through an example. Here you can see that when one packet is transmitted, then it waits for acknowledgement or negative acknowledgement. That packet will be, if the negative acknowledgement is received, that packet will be retransmitted. So the second packet will not be transmitted until and unless this first packet is received correctly at the receiver. This first packet is delivered correctly to the receiver. Okay, so this is why it is called stop and wait. And when this packet is received correctly at the receiver, then the sender will come to this state, and then the sender can send the next packet. Okay. So now if we include the sequence number, so what should be the FSM at the sender side? Again, these are 4 states. But which state is the starting state? This state is the starting state. Why? Because this has the dashed arrow. So this is start. So here it is, the sender is waiting for call for the data from the above layer. From above layer means from the application layer. When it receives the data from the application layer, so what it will do? It will makes the packets and it will compute the checksum. Why? For a bit error, because the bit error can happen, and it will attach the sequence number 0. Why? Because the acknowledgement or negative acknowledgement, it can be corrupted, but we don't use the feedback mechanism for acknowledgement. So it may be happen that the acknowledgement can become negative acknowledgement or the negative acknowledgement can become acknowledgement. So if acknowledgement can become negative acknowledgement, then the data can be duplicate. So what should we do? Okay, so we attach the sequence number to detect the duplicate packet. So since we are sending the first packet, so the first packet, it should have the sequence number 0, and this packet is transmitted. And again, when this packet is transmitted, the sent packet is stored. One copy of the packet is stored, and again it waits for acknowledgement or negative acknowledgement 0. So if the negative acknowledgement is received, then that packet will be retransmitted. Why? Because it is already stored. One copy is already stored. And if acknowledgement is received, positive acknowledgement, so then it moves to next state. It waits for the call from the above layer for 1. 1 means that the next packet, the next data which is to be sent, it will have the sequence number 1. So again the sender is now waiting for the next call. So if the acknowledgement is received, it means that the data is delivered correctly without error. Now it is waiting for the next packet, and the next packet, it will have the sequence number 1. When it receives the data from the above layer, it will make the packet, it will compute the checksum, and it will attach the sequence number 1 because first packet is sent. Okay, so this packet will be transmitted. When this packet is transmitted, one copy of this packet is stored, and it is waiting for acknowledgement or negative acknowledgement. Number 1. If negative acknowledgement is arrived, then this packet is again retransmitted because its one copy is already stored. And if the acknowledgement is arrived, so it means that the second packet is also received correctly. So the third packet will be transmitted, and the third packet will have the sequence number 0. So up to now we are using stop and wait protocol. Stop and wait means then one packet is transmitted until and unless the one packet is not received, the second packet will not be retransmitted. So the sequence number 0 and 1 is enough. Okay, so it means that the first packet, it will have sequence number 0, the second packet, it will have sequence number 1, the third packet again it will have the sequence number 0, the fourth packet will have sequence number 1, the fifth packet again it will have sequence number 0. Okay. So this is the FSM at the receiver side. This is the FSM at the receiver side. The receiver is waiting for the data from the below layer. So if it receives the data and it is corrupt, how it knows that it is corrupt? Through checksum. So it will send the negative acknowledgement. But for the negative acknowledgement and acknowledgement, we have said that they can be corrupt. So if they can corrupt, so we use the checksum, but we don't use the feedback mechanism for acknowledgement and negative acknowledgement. You can know it. We use the checksum for acknowledgement and negative acknowledgement, but we don't use the feedback for acknowledgement and negative acknowledgement. Okay. So when the receiver receives the data and it is corrupt, it is error. With error, it is a bit error, so it is discarded. And it says the negative acknowledgement, but it computes the checksum for negative acknowledgement. Okay, and then the negative acknowledgement is sent. Okay, and again it is waiting for the data for the sequence number 0. But if it receives the data and it has the sequence number 0 and it is not corrupt, it is error free, so the data from the packet is extracted and that data is delivered to the application layer. And again the acknowledgement is sent, but as we know that this acknowledgement can have bit error, so therefore it used the checksum for the acknowledgement. Checksum for the acknowledgement, and this acknowledgement is sent. Okay, and now it is waiting to receive the data with the sequence number 1. So if it is waiting for the data to receive with the sequence number 1, and it receives the data with the sequence number 0. So if it receives the data with the sequence number 0, it means that this is the duplicate data. It is the duplicate data. So this duplicate data is discarded. It is not delivered to the application. You can see that it is discarded, but it will send the acknowledgement that it is received correctly. So it will send the acknowledgement for the packet number 0. It will send the acknowledgement for packet number 0, but it will not deliver this data packet number 0 to the application layer. Why? Because packet 0 is already delivered to the application layer, and now it is waiting for the second packet with the sequence number 1. Okay, so it will discard this sequence number 0 because it is duplicate. Okay, so similarly, if it is waiting for packet number 0, sequence number 0, and it receives the packet with the sequence number 1, so it is again duplicate. It will be discarded. It will be discarded. And its acknowledgement will be sent. The acknowledgement will be sent for every time the packet is received correctly. But when the acknowledgement is sent, the checksum is computed. Why? Because the acknowledgement can have bit error. Okay, so in this case it will sense, but if it receives the data with the corrupt, it will send the negative acknowledgement and it will discard the packet. And if it receives the packet number sequence number 1 and it is error free, without error, so this data will be extracted. The data is delivered to the application layer. Okay, the data is delivered to the application layer and the acknowledgement will be sent to the sender, and the acknowledgement again checksum is computed because this acknowledgement can corrupt, and again it is sent, so it is waiting for the next packet with the sequence number 0. Okay, so up to now in RDT 2.1, in short, what we have, the packet can have bit error, so we add sequence number to the packet. Why? Because the acknowledgement or negative acknowledgement, it can corrupt. So if they can corrupt, there can be duplicate packet. So we use sequence number 0 and 1, and they are suffix. Why? Because we are sending one packet at a time. We are using stop and wait approach. If one packet is not received until and unless the first packet is not received, the second packet will not be transmitted. We must check if the received acknowledgement or negative acknowledgement is corrupted. And how we check it? By using the checksum. We attach the checksum to the data. As you know, we attach the checksum to the data to check the error, the bit error in the data, and we also attach the checksum to the acknowledgement and negative acknowledgement in order to check the bit error in the acknowledgement and negative acknowledgement. Okay, so here we have twice as many state as in RDT 2.0. Here we have 4 state in RDT sender state, 4 state in RDT 2.1. In the RDT 2.1 we have 4 states. But in the RDT 2.0 at the sender side we have 2 states. And RDT 2.0 we have in the receiver we have 1 state. But here in the RDT 2.1, at the receiver side we have 2 states. So more complexity. Okay. So the receiver must check if the received packet is duplicate. So how it is checked? It is checked through sequence number 0 or 1. Okay. So the receiver cannot know if it has its last acknowledgement or is received at the same, because for acknowledgement and negative acknowledgement we don't have feedback mechanism. The feedback mechanism is only for the data, Okay. So this class is now ends. Okay.